Imagine a planet, not like our Earth, warm and bathed in the light of its parent star. Think of a world cast out into the eternal night of interstellar space, a cosmic orphan, forever wandering the vast, dark expanse between the stars. These are the rogue planets. They are worlds without a sun, untethered from the gravitational anchor of a solar system. They drift through the Milky Way, silent and unseen, following their own lonely paths through the galaxy. We call them many names: nomads, orphans, free-floating planets. But they all describe the same profound concept: a world on an endless journey through the cosmic dark. They are a testament to the chaotic and often violent nature of the universe. These solitary worlds are not just a science fiction concept, they are very real. Our galaxy, the Milky Way, is teeming with them. In fact, astronomers now believe there could be billions, perhaps even trillions. For every star you see twinkling in the night sky, there might be dozens or even hundreds of these dark wanderers moving between them. Spotting one is like trying to find a piece of charcoal in the dead of night, miles away. Where do these cosmic orphans come from? Their story is not a gentle one. It is a tale born of chaos and gravitational violence, a story that plays out in the turbulent nurseries where stars and planets are born. Most rogue planets likely began their existence in a perfectly normal way, forming from the swirling disk of gas and dust around a young star, just like Earth did. They grew over millions of years, gathering mass and finding a stable orbit within their newfound solar system. They were once ordinary members of a planetary family, basking in the warmth of their stellar parent. But the cosmos is a dynamic and often ruthless place. The early life of a solar system is a cosmic game of billiards. Young planets jostle for position, their orbits still settling down. In this gravitational dance, some planets get a little too close to their much larger siblings, like a massive gas giant similar to Jupiter. The immense gravity of the larger planet can act like a slingshot. It can grab the smaller world and violently eject it from the system entirely. In a matter of moments, a planet can be flung out of its home, sent careening into the blackness of interstellar space at incredible speeds. Another path to becoming a rogue is even more dramatic. Sometimes, the gravitational chaos isn't just from other planets. A passing star, venturing too close to the young solar system, can wreak havoc. Its powerful gravity can disrupt the delicate balance of orbits, scattering the planets like marbles. Imagine our own solar system being buzzed by another star. The orbits of Earth, Mars, Venus could be thrown into complete disarray. Some might be sent spiraling into the sun, while others could be ejected into the lonely darkness, destined to become rogue planets themselves. By studying rogue planets, we are essentially looking at the survivors, or perhaps the victims, of the cosmic demolition derby that forges solar systems across our galaxy. What would it be like to stand on the surface of a rogue planet? The sky above would be a profound, unchanging black, but it would be studded with the brilliant, unflickering light of distant stars, a celestial tapestry far clearer than anything we see from Earth. There would be no sun, no dawn, no dusk, just the constant silent glow of the Milky Way stretching from horizon to horizon. These worlds are unimaginably cold on their surfaces, frozen solid by the near absolute zero temperatures of interstellar space. Any atmosphere they once had would likely be frozen, forming layers of nitrogen ice and oxygen ice across the landscape. But don't be so quick to write them off as completely dead. A large rogue planet, especially one with a thick hydrogen atmosphere, could trap heat radiating from its own core. This heat is a remnant from its violent formation, and is also generated by the decay of radioactive elements deep within its mantle. This internal furnace could be powerful enough to keep water liquid beneath a thick surface layer of ice, creating the tantalizing prospect of a subsurface ocean. It's a place where, in theory, life could potentially exist, completely independent of a star's energy. This idea completely redefines the habitable zone, the traditional region around a star where liquid water can exist. Life on such a world would be strange. It wouldn't rely on photosynthesis. Instead, it might thrive on chemical energy seeping from hydrothermal vents on the ocean floor. The sheer number of these worlds is perhaps the most surprising fact of all. Current estimates suggest there could be more than 100,000 rogue planets for every single star in the Milky Way. If this is true, it means the vast majority of planets in our galaxy are not orbiting stars at all. They are these dark, wandering nomads, making the universe a much more potentially lively place than we previously thought. With potentially trillions of these wandering worlds drifting through the galaxy, could one of them ever enter our solar system? And if it did, what would happen? The short answer is yes, it is possible. Given the sheer number of rogue planets and the billions of years of the galaxy's history, it's statistically inevitable that these wanderers have passed through our solar system before and will do so again. A direct collision, while not impossible, is extraordinarily unlikely. Space is just too big. The more realistic threat comes not from a direct impact but from a gravitational disturbance. You don't need a collision to cause a catastrophe. Imagine a rogue planet, even one as small as Mars, passing through the outer solar system, perhaps near the orbit of Neptune. Its gravity would be enough to subtly nudge the orbits of the outer planets. More dangerously, it could disturb the Oort cloud, sending a shower of comets hurtling toward the inner solar system. Let's imagine a more dramatic scenario. A larger rogue, say the size of Jupiter, passing through the inner solar system. The consequences would be apocalyptic. Its immense gravity would destabilize the orbits of all the planets. Earth could be pulled into a new, highly elliptical orbit, leading to extreme temperature swings that would extinguish all complex life. We could be thrown closer to the sun, boiling our oceans away, or pushed farther out into a permanent ice age. In the worst-case scenario, Earth could be ejected from the solar system entirely, becoming a cold, lifeless rogue planet itself, doomed to wander the dark forever. So, should we be worried? The odds of such a catastrophic event happening in any given year or even in the next few million years are incredibly small. The solar system is a tiny target in the vastness of the galaxy. Nevertheless, the possibility, however remote, serves as a powerful reminder of our vulnerability. We live in a dynamic, ever-changing cosmos. We are more likely to face threats from asteroids and comets that are already part of our own cosmic neighborhood, not a static, clockwork universe. We have journeyed through the dark, cold expanse of interstellar space to meet the galaxy's lonely wanderers. We've learned that rogue planets are not anomalies, they are an abundant and natural part of the cosmic landscape. Most are born in the chaotic cradles of young solar systems, violently ejected by gravitational tug-of-wars. They are frigid on the surface, may harbor hidden oceans of liquid water warmed by their own internal heat, potentially creating secret abodes for life. They are the silent majority of the planetary population, outnumbering the planets in orbit around stars by a staggering amount. Their existence expands our understanding of what a planet can be and where life might find a foothold. These discoveries paint a new picture of our galaxy. It's not just a collection of starry islands separated by an empty void. It is a dynamic realm, filled with unseen worlds on epic journeys. The space between stars is not an empty desert, it's a cosmic wilderness populated by these dark nomads. This realization forces us to confront the nature of our own existence. Our Earth, in its stable, circular orbit around a long-lived star, is a precious and perhaps rare exception. We live in a calm harbor in the midst of a vast and sometimes turbulent cosmic ocean. The story of the rogue planets is a story of chaos, exile, and survival against the odds. While the direct threat of a rogue planet disrupting our solar system is exceedingly low, the idea itself highlights our cosmic vulnerability and the delicate gravitational balance that makes our existence possible. For billions of years, Earth has been fortunate, avoiding any catastrophic gravitational encounters. We are lucky survivors in a universe where being flung into the eternal night is a common fate for a young world. The study of these wanderers is not just about satisfying our curiosity, it's about understanding the full range of possibilities in the universe and in doing so, better appreciating the stability and safety we currently enjoy. And it leaves us with a final, profound question. If life can exist on these dark, lonely worlds, what other incredible possibilities are we yet to even imagine?